Test, test. All right, I think we'll just get started in a couple. I know, like, and then we'll just go from there. All right, normally we're more punctual. Require people, point people. Are you surprised? 0 people sat in the first row.
No one wants to sit in the last row because they don't want to look like a.
But if you don't have the first row, then they will not, like, if we made this the first row, nobody sat, already nobody sat.
You can't sit in the back row because it's not like the calculus.
I'm going to slide this under here if that's okay.
Yeah, yeah.
All right. My notes for the meetup. Oh man, it's super bright right there. I'll move over to here. Hopefully that's okay. All right, I'm going to get started, and I think we'll have a couple stragglers. I don't know. Last time we were here, we had 25, so I'm sort of expecting a number around there. I want to thank Qualcomm for having us, and the engineering development team, and specifically like Drew and Urivan for sort of setting everything up and making sure that, you know, they know that we're coming, for example. So that was awesome. And I want to thank Jeremy right here, who helps set up all the speakers so that we have good talks. We have 2 remote speakers tonight and 1 in-person speaker. The in-person speaker was here but ran off to get pizza, and now they're not back yet. So, but they'll be here, I think. And I don't want to tempt fate, but there's supposed to be pizza for more than just Hobson, and Hobson is sponsoring the pizza along with Tangible AI. So I want to thank them. Hopefully, he was good. I know, but I don't want to like jinx it. You know, like if you say it out loud and then it doesn't happen, you feel bad. Anyway, I want to thank Hobson and Tangible AI. Even if the pizza doesn't come through, Hobson's been great. Tangible AI has been great. Cool. There is a Saturday meetup for those who don't attend San Diego Python. If you don't know anything, the Saturday meetup is different from the once a month Thursday meetup. This one, the Saturday meetup is online. It meets on Discord. You can get to the Discord off of sandiegopython.org. It's kind of like a bring your own laptop, work on your own project, meet other people who are working on projects, that kind of a thing. Some people like break out into their own rooms. So it's a digital meetup, and yeah, it doesn't have speakers usually. Occasionally they do like have somebody give a talk if they're practicing for something or something like that. But usually it doesn't have like a speaker lineup like this one. Anyway, it's Saturdays, it's 10 a.m. And check the meetup page for the latest info. It's all there. If you are struggling to get on the Wi-Fi, the process is a little complicated. It is QGuest, that's the Wi-Fi, and then you sign up on there, and then they email you a code that you have to put in, which is tricky because if you are on your device that needs the Wi-Fi to get the email, well, things get complicated. So hopefully you can get there. Anyway, we're San Diego Python. The website is sandiegopython.org. There's a link to the YouTube channel. We're streaming the meetup. Our meetups are streamed live, or at least the Thursday ones are. You can get to the Discord from there. There's a jobs channel in the Discord. So if you're looking for work, that kind of a thing, there actually is like, it gets multiple posts a month, local companies. So, and even if that's not exactly what you're looking for, it might point you in the right direction. So check it out. And the Discord has other things, like there's channels in there for web development or biotech, all sorts of stuff. So I did want to mention a couple upcoming conferences that are happening in the next month or so. I figure I'll just give them a shout out. PyGotham is on October 6th to 7th. It's in New York City or online. So that's happening. DjangoCon US is in Durham, North Carolina. That's October 16th to 20th. Some of those days are like the tutorials and stuff. So I think the conference, it's usually just 2 days of conference days, or 3 days maybe. Yeah, anyway, it's in Durham this year. Can't be here every year. It was here last year, so that was cool. Also, I'm gonna pressure everybody to be a speaker a little bit. You know, the meetup kind of runs on speakers. Like that's how we keep the meetup going. So if you are interested in giving a talk, you can sign up on our website. You don't have to sign up for the next meetup. You could sign up for 2 meetups from now if you're not feeling like you're ready to give a talk. We are looking for talks at all skill levels. So like, you know, whether it's don't feel like you don't know enough to give a talk. Everybody knows enough to give a talk. Like the talks are just at all skill levels, but the people who come to the meetup are of all skill levels. So that's okay. Like if you want to give an advanced talk, great. If you want to give a beginner talk, that's great. Anywhere in the middle, that's also fine. So please give a talk. I also want to give a shout out to our sponsor, JFrog. They are a DevOps platform for continuous releases. Like if you needed to host an internal PyPI inside your company firewall, their product does that along with other things. So, you know, if that's a thing that you need, check out JFrog. They've been really generous to San Diego Python. They gave us a giveaway to give away, which I have the winners drawn here. So hopefully you're present. Otherwise, I will save it for next time, or maybe these people will show up a little later, and that'll be okay too. Yeah, so they gave me an Adafruit PyPortal to give away. It's like a CircuitPython programmable digital display. So you can, it's not like a 640 by 480. I think it's smaller. I think it's like 320 by something. But it's like a little LCD display. And if you win it, I'm going to pressure you to give a talk on it, but just a little bit of pressure, not too much pressure, but definitely a little bit of pressure. And I have a couple other, these are, I think, things that go along with it. One of them is, yeah, well, these are just things that go along with it. I think it's like a little thing that lights up and like you can program it, like you can hook it into one of the connectors on here and it lights up. Anyway, is Ryan Sullivan here? Boom, you are the winner. You're the winner. Congratulations. Woo! Yeah, you got to be present to win. So you're present. You won. Awesome. So when you have programmed on your Python programmable digital display, you know, when you've programmed on it and you feel like you're ready, then, you know, a talk would be fantastic. Cool. I guess our first digital speaker is not here yet, right? Is Attila online yet?
Let's see. That one, maybe turn.
Okay, should we check that? And then maybe for Trey, we'll push him. And Hobson has not returned with the pizza.
First of all, let's see. Are there any? Let's see. Are there any jobs seekers or let's see, job postings that you would like to tell others about?
Anybody's company hiring? Oh.
Job seekers. Cool. Sweet. Let's see. What are you looking for?
Well,
Are you on our Discord?
I'm not.
Okay. There is a jobs channel on there. Check it out. With a remote.
There's
Let's
also
see.
several
You have to
data
switch
science
accounts again.
related meetings.
You have to switch.
Event.
Set it up and.
Hey, very cool. All right. Can you hear me? We can't hear you. Just a moment. Open this up to
Let's see
everybody.
if we can get the audio.
Nice. No.
That part's your audio is definitely
Okay.
coming in there. I will join.
We're going to go ahead and let's see. you get to be the first speaker as soon as you can speak. So. Hey, we did hear it. Let's see, just a little bit.
Well, let me
It's
turn
very,
up the
very-
room audio.
we're gonna-
'cause I turned it way down.
All right,
Very
keep on saying testing.
I think he's about the right level.
I think you're coming in clear now.
Okay, that's great. Oh,
Woohoo!
All
All
right, let's full screen it. All right, we're gonna full screen you and then turn it around so that you can see the audience, and then yeah, we'll go from there. Oh yeah,
right.
you want to read it? Or well, I guess first of all, our first speaker is Attila Toth, who's going to talk to us about working with ScyllaDB in Python. Did I get that right?
Yes, you actually pronounced it right. Yes.
Okay, I'm gonna see if I can full screen you, and then do you know how to full screen? You probably know better than me. It's your computer. Let's be honest. Hey, that's better. And then this is pretty good actually. All right, I'm gonna turn you around so that you can see the audience. Then we'll go.
Oh, that would be awesome.
Okay, I'm turning you around. Quick, everyone. And then yeah.
Okay.
Hey.
Hey, everybody.
All right, you're on.
Great. Can I start?
Yeah.
Okay, let me share my screen real quick. Do. Okay, so you should be able to see my screen now. So hey everybody, thank you for having me. This is actually the first time I present at a conference this way. So this should be fun. Let me quickly start a stopwatch on my other screen so I don't run over. All right, so let me get started. So just real quickly about me. So my name is Attila Toth. I'm a developer advocate at ScyllaDB. I've been working as either software engineer or a developer advocate in the data space for the past more than 6 years. And as you noticed, I'm not there with you. I actually live in Budapest, Hungary. So actually forgive me if I sound tired. It's kind of early morning for me, but I will try my best. So first of all, what is ScyllaDB? If you don't know about ScyllaDB, or if you haven't heard about it yet, just real quick, we have a lot of stuff on this slide. I'm just going to highlight some of the keywords that you might want to remember. So ScyllaDB is a NoSQL database. It's a drop-in replacement for Cassandra and DynamoDB. And it has superior performance over legacy NoSQL. You can avoid vendor lock-in if you use ScyllaDB. We have an open source version, which means that you can run ScyllaDB yourself anywhere, totally for free if you want to. At the same time, there's also a cloud offering for ScyllaDB, and you can choose between AWS and Google Cloud Platform as your infrastructure providers. And there are so many databases out there. Why would you consider using ScyllaDB? I just put some keywords there. If you recognize any of them as your requirements in your projects, so things like high availability, low latency, high throughput, and big data scale. So if you have all of these or some of these as your requirements for a database in your project, ScyllaDB might be a great choice for you. All right, now I'm going to jump over to VS Code real quickly. I hope you can, let me try to increase okay. I hope you can see that. And what I will do is, we have this sample application that you can find even after the conference if you want to check it out, iot.scylladb.com. It's a sample pet application, so you can set up an application with ScyllaDB to monitor pets' health data, so things like temperature and heart rate and things like that. This is kind of a fun project to help you get started with ScyllaDB. So that's what I'm going to use now. And basically, I'm going to show you how to do the basic database things in Python with ScyllaDB. So the very first thing you need to do is install the ScyllaDB driver. And it's going to be pip install Scylla driver. I already have it installed, but that's how you install it. And then once you are in Python, you need to import the cluster module, which if you notice is actually we're using the Cassandra module. Why is that? Well, I mentioned that ScyllaDB is Cassandra compatible, and in the case of Python, we are actually the ScyllaDB driver is a forked version of the Cassandra driver, so that's why you might see Cassandra here and there. So we need to import this module, and then the easiest and the most basic example to connect to an existing ScyllaDB instance is to create a cluster object and then use the IP address of your ScyllaDB host. In my case, I'm just running Docker, so I have a local Docker container with ScyllaDB. That is probably the easiest way for you to also host Docker to host ScyllaDB locally on your computer. So I'm defining the IP address, and then I connect using a cluster connect, and then basically that's how I create a connection. So it's kind of simple so far. And then to query data, you can use this piece of code. I'm using CQL, which is Cassandra Query Language. That's the primary language for interacting with ScyllaDB. It's very similar to SQL. As you can see here, to do a simple select statement, it literally looks the same as what you would write in SQL. And then if I run this, what I get back is a list of row objects, or I can also prettify the output, so I can just get the actual values. Now in this table, I only have one row, so that's why you only see one value. And then you can also insert data. Again, the syntax will be very similar here as in regular SQL. Just insert into, and then we have this carpet thing. Carpet is what we call key space in CQL. In regular SQL, you would call this a schema. And then you define the name of the table. You define the columns. So owner ID, address, and name in this case. And then we are inserting values using placeholders. In this case, we are inserting Homer Simpson and his home address. So if I run this, let's check if Homer Simpson has actually been inserted in the database by running another select query where we are filtering by owner ID. So if I run this, we see that Homer Simpson is in the database. So it worked, and that's the very basic way how you would interact with a ScyllaDB table in Python. Again, if you want to run this example and do much more, you can, after the conference, you can go to iot.scylladb.com and you can just run this very fun Python example. And that's all I wanted to share. If after the conference people want to ask questions or just reach out, please feel free to do so. My email is attila.toth@scylladb.com. You can also find me on Twitter or X, sorry, at attila.dev. So that's it. Thank you very much for your attention. I hope you will have a great meetup.
So we hopefully you can still hear us, but did anybody
Yes.
have any questions they wanted to ask? I thought I saw a question.
Go with something besides SQL.
Yeah, so Jeremy's asking, why would somebody choose ScyllaDB? Like, what would be the primary reason to choose it over something else?
Yes, so I mentioned some of the keywords, so things like high availability. So if you care about high availability, high performance, high throughput, and low latency, we even have a conference called P99Conf, because for a lot of ScyllaDB users, P99 latency is a very important metric for them. For example, some of them might require a P99 latency of less than 10 milliseconds, and you can do that with ScyllaDB. So if you want a really high performance database and you have lots of data, and a regular SQL database just doesn't cut it anymore, then ScyllaDB might be a good choice. IoT.ScyllaDB.com. Yes, correct. I don't know if it helps, but I put it in the YouTube chat. Or yeah. Yes. Thank you. Thanks for having me. Have a great meetup. Yeah, 4:30, but yeah, it's fine. Thank you. No worries. Thank you. Bye-bye.
So I didn't hear from Trey. Hobson ran away. Who was here? Trey sent me because I'm ready, but he's not in the call.
Yeah. Okay. Let's see. Quick.
So I send
Yeah, send him the link.
I'll send- Oh, he's here. Okay.
Woohoo!
You are here.
All right.
Can you hear us? Okay.
Can you hear us? Okay, testing, 1, 2, 3, 4. Turn on.
Oh, we could hear him for a second.
Anyway, this
I'm muted, but you're not muted.
now.
Oh, he's muted. He's now muted.
Oh.
Oh, so I message on.
Yeah.
We're ready for it.
And but how come we're not broadcasting?
Yeah.
No. Hey. Testing, 1, 2, 3, 4.
I think you're coming in okay. Like I can see.
Yeah, I can hear you.
Okay, good.
Yep,
Just
you're
making
coming
sure.
in okay.
Yeah. Well, I didn't know if this would be on the stream or here, so sorry about that.
Oh, you're good. I'll just give you an introduction and then we'll go from there. How does that sound?
Sounds great. Thanks.
All right. Trey Landsburg is our next speaker, and Trey's going to talk to us about Librosa, which is a Python audio analysis library. Is that pretty good?
Yeah. Sounds good. Let me just share my screen here. All right. Can everyone see my screen here? Okay. Okay. Sorry about that. Let me try it again. Okay. How about now? Yeah, I recently got a new desktop, and when I share in Teams, it has a bunch of different options that I haven't seen before for sharing. So sorry about that. Anyways, my name is Trey Landsburg. I actually work with Jeremy. I'm up in San Francisco. And I'm going to talk about Librosa today, which actually isn't something that I really knew much about before I kind of made this presentation. It's a library that I was interested in because of its applications with audio classification. And so Librosa is just a way to basically just read in different audio files and then give different statistics on those files. So, like I said, this is not something, full disclosure, this isn't a topic that I'm very well versed in. This is kind of a learning experience for myself as well. So I borrowed heavily from these different sources, and under each slide, you'll be able to kind of see them. These two Medium articles are really good in this YouTube video. So a little basic science review, just a few terms that you need to know when using Librosa. So amplitude, it's responsible for the loudness of the sound. Frequency, it's the speed at which the amplitude changes. So this is the pitch that we normally think of with natural hearing. And then sounds that we hear consist of multiple sound waves of different frequencies. And when they're summed together, they make new sounds. So how are sound waves digitally stored? We can't store a continuous wave like in nature. So we have to do a sampling where we take discrete samples of a sound wave. And that's what gives a sound a sampling rate, and that sampling rate, depending on how high it is leads to what type of quality we're going to have in the digitally stored audio. So, for example, if anyone can still remember what a CD is, the sampling rate for that was 44.1 kilohertz, which means that the samples were taken 44,100 times per second. So here's some graphs that just kind of help you understand more about that sampling rate. So I like this one on the side because it shows that the higher sampling rate, there's more detail because it's happening, you're getting more samples in that discrete amount of time, where a lower quality audio will have less samples, so it'll be less detailed in that same amount of time. I'll skip over this for time. Well, I guess we can go over this. This is just a better representation of what high frequency versus the low frequency is. The high frequency, it's higher pitches right away, and then the lower frequency, it's more of a valley in between. So getting into what we're talking about here in Librosa, this is Python's audio analysis library, and so there's a few different things with it to know kind of right away. To actually load the file, you use this librosa.load, and this is actually loading a single audio file from a list. In this case, it's a WAV file. And then the Y represents the actual array of data, the raw data of the audio file, and the SR is the sampling rate. So for this audio file, it was 22,050. And you can do some other things with it, the normal types of array manipulations with the NumPy. So we're just looking at the first few values, the shape of the NumPy array, and then just printing out the sampling right here. So Librosa is really good. I mean, obviously, no one you can look at big arrays of data, but Librosa is really good for using for plotting data. Getting that data ready to be plotted either by matplotlib or some other type of Python library, or with some of Librosa's, they're in the plotting within the library itself. So this example here just shows we have a NumPy, we have a NumPy array, and then we're converting it into a series, and we're plotting that. And then you can see that there's some silence in the beginning and the end of the file. And so to trim that out to make the graph a little bit more visually useful, you can actually trim it out with this built-in effects trim for Librosa to actually trim out the tails that are not useful. So you can see here that if you we say top dB equals 20, then it's going to basically eliminate anything on this graph that doesn't go above, anything in this graph that is at 0, because it needs to be at least 20. So we have a much more useful audio graph. So we have the loudness, the decibel, and then we have the time. I know I'm probably going a little bit over, but I'll just quickly go over 2 more useful plots within Librosa. One is a spectrogram, and this actually shows what parts of the frequency are the most powerful in the audio image. So this uses this short time Fourier transformation to actually transform that series to be used. And then this actually it basically converts it from amplitude to decibel, and the decibel is like the standard for Librosa. And this, like I said before, just kind of shows which frequencies within this audio file are most powerful within it. Finally, we'll have the melodic spectrogram. This actually focuses on the frequencies that the human ear can hear in general. So this one is all frequencies, including the frequencies that we can't hear. And this MEL spectrogram, the melodic spectrogram, focuses on those frequencies that we can specifically hear with the human ear. So that's kind of a short, fast introduction to Librosa. There's obviously a lot more to it. I hope to kind of dive into it more and present a little bit more, and then maybe eventually, show some working code that I've kind of, worked up with it. So that's about it. Thanks for listening.
Thank you. Are you willing to take questions from the audience?
I can the best I can. Like I said, it's something that I'm learning myself, but there are some, I'm happy to.
Anybody have any questions? Yeah, go ahead.
I think what it means in this context is like the loudness of that frequency, the loudness of that decibel. So how loud is that particular frequency? How far are those tails going up? Yeah.
Any other questions?
Which obviously that spectrogram helps because it shows it. I mean, you can't, if you try to show that, it would be, with the first chart that I showed, it would be very difficult to see, but that spectrogram shows it a little more detail.
Go ahead.
What about different audio formats? Convert it to wave, or can you analyze others?
The question
Sorry.
about
Yeah.
audio formats, because microphone speak. Asked about.
Yeah, I can handle different audio formats. The example that I was using was a WAV file, but it can do other ones. And if not, you can use, you can convert the files as well. But I know it does use at least MP3 and WAV.
Thank you very much, Trey.
Yep. Thank you.
Appreciate it. All right. I'm going to pick this back up. So Hobson, you're our final speaker, and you're back, so that's good. Do you want to talk, or should we take a pizza break, or you want to have a pizza break? All right, we're gonna take like, I don't know, 10 for pizza or something, because there's pizza right there. So let's we'll just pause the stream, and then we'll get to Hobson's presentation in 10 minutes. How does that sound? All right. I guess we don't need this anymore, and then I'll just back to the pre-show. All right. We're good. Pizza? Think Hobson? I'll show. That's it. You're ready, go ahead and set up. Good. Audio is still coming in from the presentation?
It's loud.
Yeah, repeat questions on the right. You're a Linux Mint user? I thought you were a new Linux user.
Oh, I was until they went evil.
Oh, how are they evil now?
Everybody's evil in my mind, aren't they? They are requiring people to use snaps, which they are the only ones who host the snaps repository. And but fortunately, they backed off. There was such an uproar about it. They backed off. But they're going to eventually do it.
Some people are all about snaps, some people are all about flat packing.
Well, I like the snaps. I like the format, I like the whole idea. But this, however, it's awesome. Back in there now. Okay. Services like what's there. You can, but you couldn't. No, I'm trying to get connected to the internet. Just a second. Yeah. Fish is. Did he bring you your pizza?
He did.
Oh yeah, definitely. You can totally enter your password if this doesn't work. Because
Okay. I have it if you're ready, or when you're ready. If you,
what's your username?
it's my email, which I'm gonna mute this real quick. Okay. See the Linux.
This is gonna be tricky. Yeah. Right. Oh.
No.
Got it. Do whatever you need to do. Whatever.
Yeah, and I'll give you the file.
Using Llama 90 billion or. Oh. All right. Go ahead.
When you're all set, all set.
Yeah,
Take your
great.
time. Hobson was ahead.
Sorry?
Oh, sorry. A little bit. A bit. Oh,
Perfect. I just wanted to do a demo. Awesome. And I'll just run that.
Yes. Will I intro you?
Yes, please.
Okay, our final speaker tonight, who also brought the pizza, thank you very much, Hobson, is Hobson Lane. And Hobson's going to talk to us about how to host your own ChatGPT-like service on your laptop. And I'm going to put this here so that it actually picks you up.
Awesome. I'm Hobson Lane, Tangible AI, CTO. And we are building chatbots for social good for nonprofits. And we're now learning that we need to incorporate large language models so that our customers, our nonprofit customers, can say that they're using them so that they can please their donors. And not so much that they're needed for the kinds of applications we do, like nursing bots in Africa, a nurse NISA bot in Africa, teaching math in Africa, teaching about child trafficking in Nepal. So those kinds of bots are much better implemented in a rule-based system. But I'm going to show you how to use large language models and how to host them yourself, so you don't have to pay anybody, and you can be completely private. You can have your users sharing medical information without it going to OpenAI or somebody. And so this is a class, obviously, that and you can the key elements that you need in order to run a llama-based tokenizer, a llama-based large language model would be, who knows? Raise your hand if you know what a large language model is. Awesome. Okay, a large language model is, that was more than half. A large language model is predicting the next word with a particularly large neural network to accomplish that task. And the reason why they put that, why L is such a big, the large, LLMs are what they're called. The large is a big deal because a lot of things happened so much better when we got large. And they seem, people claim that emergent properties are happening. I don't believe them. I don't see them myself in the data. Vish and I have debates about this all the time. But what I do see is they get better and better at fooling us by parroting what's called a stochastic parrot. I'm not alone in this belief. Timnit Gebru and Melanie Mitchell at Google were fired for this opinion because they told them that there's some danger in large language models, and they would not even publish a paper in which they wanted to reveal their research. And they were the founders of the AI ethics department at Google, and they were fired for daring to admit that there are some dangers in these large language models, biases and such that are encoded into these models. So anyway, how do you do it yourself? So you don't have to rely on some big corporation and do it correctly and ethically. Well, you need to this Llama tokenizer and the Llama model, the whole Llama chain of balls includes Vicuna, which is now it's the 6th on the leaderboard for intelligence on and you can go to metaculus.com if you want to see the latest bets and predictions about who's going to be best and when a non-commercial model is going to break into the top 5. Vicuna is the closest into breaking into the top 5, along with GPT-4 and GPT 3.5. So you needed these two classes. You import them from the Transformers package by Hugging Face, who are trying to democratize natural language processing and AI in general. And you need to have an authorization token you can apply to Meta. They'll get back to you within 10 minutes probably on your application. It's just a checkbox to say basically if you ever have more than, I think it's 1 million customers, then and you can't use it commercially. And so they just don't want you using it to compete back with them because they sponsored the development local model. But you can use Vicuna and others that derive from it without having to check having to apply for that license, and just using your honor system to say, yeah, if I ever have 1 million customers, I won't compete. So it's completely unenforceable. It's what's called business source. It's not open source. Claim to be business source, but they can change the license at any time, and they can change the terms of service that allow you to use that license.
And you obviously have to apply for a license just to download the weights. So that's not open source. But it's a real simple process. Just give them your email and you're good to go. And then if you can give that, there's a slight, for some reason, I had to use this other argument called use auth token that's been deprecated. So in the actual documentation, not supposed to do this. But this is what had to work for me. It would give me a different error beside the deprecation warning. If I use the normal token. Anyway, so this code works. And I'll post it somehow associated with this presentation. And so if you want to have an interaction with it, and I'll just go ahead and get it running, so that because it does take a long time to generate a single prediction of the next token. I'll just bring this over here. How this goes. So this is firing up it's running that code right there. It's initializing that model. It's downloading. It would download automatically the weights that are required for that model, but because I've already downloaded them, it just brings them from the cache. So just loading them from the cache on disk is taking this much time. I've got the smaller model. It's a $7 billion, weight value. So it's 7 gigabytes of if each one was a byte, it would be 7 gigabytes. But they're not. It's like 15 bytes. So it's a lot. It takes up 33 gigabytes when I load it, along with Python and all the other things I have running on my laptop. Okay, so I finally got a prompt. Let's get that bigger so we can see it. So unfortunately, the $7 billion model is not too smart. Sorry, I haven't even gotten to the funny part yet. Can't get this. Oh, that's right. It's capturing my keystrokes, so I can't expand. Oh, should load faster. Now I can do. There we go. Okay, so wait for a second. While that's loading, 7 billion parameters that are learned. Large language models have these new properties where they seem like they're reasoning, but they're actually just predicting the next word. And you'll see how you prompt them as a raw. When you get it from ChatGPT, they have wrapped it with all these prompts that I'm going to show you here, where you say, like, the human says this, AI says that. You give it some introduction about what the AI is supposed to do, what role they're supposed to play, called the system prompt. It's called prompt engineering as you're putting all the words around it, because these models were trained to have a conversation with and predict the next word in that conversation. They're just finding the next word. And because they have read all of Reddit, all of Stack Overflow, almost all of GitHub, they have a lot of text to predict, and there's very little you can ask it or say that hasn't been asked or said somewhere else. And so it can find that pattern very closely. So you have to work really hard to test these on actual reasoning. And so the question I came up with was, I don't know if I should do that, but first let's just ask it an easy one. Unfortunately, this is a small model, so this is not really a fair test, but what is an LLM? So same question I asked you. So what I did was in that class, I send it a prompt before it says human to text, so it knows where this text came from. It knows that it's participating in a dialogue. So then I gave it a prompt, and Llama likes to be called an AI assistant. It doesn't even know that it's Llama. You could say, or say you. It doesn't really do well if you just give it unprompted, ask it a question. And so obviously it doesn't even know what a large language model is, but it knows the real meaning of LLM before LLMs came on the tech scene. So it is an actual degree, and you have to be very careful. One thing that ChatGPT-4 can't do is shut up. You can tell it to shut up, you can tell it to stop saying, you can tell it don't reply, and it will always reply. It's trying to pick the next word in a dialogue. It has no concept of nothing. It has no concept of not predicting not the next word, or whatever. But they haven't built into it the ability to shut up. But if you do tell a large language model to be concise, it will do that. It's really hard to get it to not be verbose, because it's really good at what it does, picking the next word. You can see this is grammatically correct. This is something that was really hard to do 3 years ago. Generate a grammatically correct, plausible answer to almost any question you could possibly answer. The key is just plausible, and it looks smart because it's been trained to get those like buttons. The human in the loop feedback, HLRF, you might have heard of, reinforcement, or RLHF, reinforcement learning human feedback. That's training the trainer. The humans are training the trainer, and they're telling it what is good. The way they're telling it what is good is by giving it that thumbs up that you're giving it. You're training their model for them to make money off of you every time you hit that like button or the down like button, especially if you spend any time in correcting the response. But as you can imagine, it's a popularity contest. This is not a factual correctness contest. This is not an unbiased, objective opinion contest. It's just like Reddit. And so this is the kind of stuff, the biases that end up inside these large language models. Even when they pay those raters in Africa less than $1 an hour to do this work of rating hundreds of these things per hour, they are still subject to their own biases. And they're still not experts at everything that's been written about on the internet. And so their feedback is not any better than yours and mine, or anybody who's just trying to I don't know, whatever, have fun. It's not being as smart and concise. It's not being super concise. It's a very long sentence.
Is this the kind of thing faster?
Oh, absolutely. So yeah, this is running on a 8-core CPU, and it's not even using them all up. Okay, finally back. Okay, let's call it a better question. Let's do a math. Another thing it can't do is math. It's a freaking computer. Why can't it do math? A calculator can do math. Why can't this thing do math? There are 2 cows and 2 bulls, and 1 bull had a leg amputated. How many legs of cattle are there? I chose those words very specifically to trigger a pattern in it. It's heard of head of cow from cowboys and ranchers and lot feed farms where they count up the existence of cows by their heads. So it's going to answer. It's going to see that as a pattern. See leg of cow. Oh, it must be like head of cow. So and the numbers that are associated with the head of cattle are just 1 per cow. So it's going to give me numbers like 4 or multiples of 4, but it's unlikely to give me the correct answer. There you go. So it's not doing. You could ask it to do its reasoning about it, and it would give you some plausible reasoning. But often there's a contradiction hidden somewhere in its reasoning. This is typical of. This is not just the dumb models like Llama 7, Llama 2, 7 billion parameters. The largest is. Now I'll show you the larger one. Unless somebody have a quick one. We only have time for one more question. Anybody have another question they'd like to ask it? Go for it.
What is the smallest prime larger than 100,000?
Oh gosh.
I know what it is, by the way, because I asked. Give me a prime.
The question is, how do I do 100,000? Do I put a comma in it? Do I put it as words? And should I put a question mark? Okay, it knows that to shut up. Okay, this is probably a bug in the way that I've implemented. I haven't, I'm not 100% certain that I'm sending it that human prompt in the right way at the beginning of the time. I'm not sure that it's seeing that text that you're seeing exactly as you're seeing it. That's, I've never seen that before. Ask it an unanswerable question. Okay, it's caught in a loop. Sorry. I'd have to start over, and we can start over, but it'd be better to ask a smarter model anyway. I'll go ahead and get that running again while we visit over. So Vish has graciously offered to give us access to a resource where he is hosting a llama to 70 billion, 70 billion. And what do I do? Do I just hit run? Okay. In an IPython console. That's what I didn't want to do. Is there any web interface? Anyway, I'll try. I just don't know that everybody's going to want to wait around for me to install something, especially since I don't even have my. NLP Cloud. Okay, great. Okay. Now what do I do? Is this what just happened? Yeah. So that I just asked it this. Got it. Never mind. I should have practiced this. So you give it the history. Got it. And you give it those two pieces. So I'd have to go and edit this, and it would then do whatever we asked it to do in that last question. Well, there's no question. What is it answering a question? How do I see the? Got it. I just broke up with my girlfriend. That's a doc string though, and it's recognizing that as the. Interesting. Okay. So okay, we only have one more shot at this. Let's ask it. Let's see. Does an LLM know how to reason? Now, I'm gonna have to change the context about world, real world. Another really good question to ask large language models is, how do you know when you're mistaken or making a logical error about things in the physical world? And at least the versions of Vicuna that I asked that question, it answered it really well. It said, I can't, I don't know. You ask ChatGPT. Because I haven't lived in the world, I haven't gotten feedback from the real world, so I have no idea what goes on in the real world. I'm only a large language model. Whereas if you ask that of GPT-4 or ChatGPT, it will go on and on about how well it can read and how well it can. It says I check for consistency and logical errors. It goes through all the things that a human would say. They know that they're wrong. How they know when they're wrong about the real world. It thinks it's human. The way that because it's been trained to act like it. Is there any way I can get this question to go into it and have a sensible answer? Is there a better context I could ask it than this? Fish. Sorry for the live coding here. Can I get rid of this other context history? No, LLMs are not designed to reason about the world. Llama for the win. So that's it. Thank you.
Want to take questions?
Questions?
Realize that it's
Yeah. So that bug that we saw where it was kept saying human, you answer the question, please. How can we avoid that? Does anybody have any ideas? I know the answer. How would you do it? You would write a freaking program. Is this answer the same as the last answer to the same question? And if it is, and then do something else. You would change the temperature, you would change the prompt, you would say try something else, you would add some prefix or suffix to the prompt. You would have a rule-based system that detects very common errors. Vish is working on founding, he's decided to go off and take a chance for the next 3 or 4 months. He's going to give it a shot at building a combination of large language models with rule-based systems, a knowledge graph, and a retrieval-based augmented generative model to keep his dream of Cleverly.io alive. Go to him for the spelling of Cleverly. It's not spelled correctly, but it's a really exciting project. He has a really good chance of beating some of the best. There is another tutor bot out there for doing a lot of the stuff he does, but the last time he did this, his model was better than this company that just received $10 million in investment. So he's really good at this. But you build a rule-based system that you wrap around the non-completely, the word manipulation model that is a large language model. You don't use a large language model to do any kind of logic, including reasoning about what the user wants to have happen next. That is a favorite of a lot of people. Including Vish and I are having an argument about this right now, but there is a concept. In fact, I think that Vicuna was trained this way, where you use a large language model, the largest large language model you can find, as the rater of another smaller large language model. So you use GPT-4 with their open public API that you have to pay for. You use it to rate your model and give it the reasons for why that answer is good or bad. And then you have humans look at that and say when the GPT-4 says it was bad, and they found there were 7 categories. Vish can explain all this a lot better than me. But there were 7 categories of questions that they found, and some of them GPT-4 was really bad at, like logical reasoning and all these others. So even its judgment of another thing was bad, so they had the humans' ratings overrule what GPT-4 was saying. So you have to build another machine learning model to follow what's going on, to rate the output of the model. This whole concept of rating the rater, having the humans rate the rater, and then have the rater rate thousands. For every one human rating, there's 1,000 ratings that are coming out of the rating algorithm. that's used to actually do the reinforcement learning on that algorithm. That's the RLHF approach, and that's what made GPT so successful at looking smart, appearing to be smart, being able to predict the next word that's going to get that thumbs up from you. Yes, Fish? Mm-hmm. It's not reasoning at all. You're giving it a pattern of words to follow. So retrieval-based augmentation, so Vish asked about a particular thing called a RAG, a retrieval augmented generative model. And the way that I'm familiar with that, what you do is retrieval means search. So you have a search engine, goes and searches for that answer, just like Google. It gets a bunch of text passages from a bunch of documents, usually Wikipedia, and you paste that in the prompt. And you say, hey, ChatGPT, this is from Wikipedia. Hey, this is from the New York Times. Hey, this is from whatever. Can you answer this question about that text? And that's something it's really good at. It can see the pattern in the question. Is it looking for a person, place, or thing? Is it a what, why, or where, or how? It knows how to form a grammatically correct sentence. It sees the facts that are in there that are stated, the names of people, places, and things that are appearing up there, and it looks for those things and figures out what associates with what. It's an attention matrix that it built. Its whole brain is nothing but attention is all you need. It was a paper that created this whole craze about transformers. Transformers are the particular kind of model that's layered up to create these things. A large language model could typically have more than 100 of these transformer layers. At the core, each layer is a big matrix of all the words and their relationship to the other words in that one and how strong that relationship is. It's just a matrix of weights. So if you have 1,000 tokens on the input, most of them are limited on that the tokens on the input. So you have 1,000 tokens inputs, you have 1,000 by 1,000, you have 1,000,000 weights that are telling you just about that first layer about what that sentence means. And then it transforms that layer into a new vector, and then that goes into the next layer, and that same matrix that applies to it, where it says, okay, this pair of words is related to this other pair of words, which were connected below. They're connected again up here in a different way, in a different combination, sort of a hierarchical. But each layer is identical, and that was the huge breakthrough with transformers. Instead of necking down the information and making it less and more and more compact, more and more dense with information and thought and reasoning, or whatever you want to call it, instead, each layer is exactly the same as the one before it, so you can stack them up forever. And so that's the encoder, and then you have the decoder, which does that same thing in reverse and decides what, and at the end you get a vector, a sequence of vectors, and that sequence of vectors corresponds to a sequence of tokens. But it's all just matrix multiplication all the way up. And to answer David's question earlier, that's why GPUs are good at this, because that's what you're doing when you're playing video games. That's what GPUs are designed to do, is do that big matrix multiplication of all the pixels on your screen multiplied by a 3x3 matrix, or actually it's usually a 4x4 homogeneous matrix to do the transformation of a 3D model into that 2D space. So it's just a big matrix multiplication. That's what transformers do. That's why GPUs are good at it. But that's very, very similar, just a fully connected network. There's some other tricks you need to do because it has enough weights in those 7 billion weights, or I guess it's more than a trillion weights in the case of GPT-4. It has enough there to memorize pretty much everything you feed. Memorize it verbatim. And it doesn't have to generalize a whole lot. It doesn't have to make connections between actual physical phenomena in each other. Got a great capacity for memory. If you think about it, that's a lot of information. A terabyte of information is more than Wikipedia, much more than Wikipedia. I'm not sure what it is, but with this Wikipedia, it's like 10 gigabytes of text. So it could literally memorize Wikipedia 1,000 times over. Yes. What about any what about running it on the GPU? What? You can use a lot of different libraries. CUDA is the most popular. It's the only one that will work on NVIDIA. You don't need to use CUDA. You can use OpenGL, open graphical modeling language. But that will only work on AMD RTX. I forget what they're. Unfortunately, NVIDIA's gone evil as well. You're looking for another evil company. They are actively trying to prevent Linux from building drivers that work for NVIDIA cards. They're actively sabotaging their own hardware so that it can't be figured out and reverse engineered. And the lead open source developer of those open source drivers for NVIDIA cards just quit. He said, "F it, I'm done." So you're not going to ever see that work on Linux anymore. I'm throwing away my NVIDIA cards. I'm going AMD. It's exactly the multiplication of it's exactly that number of multiplication. If I did the math on that 7 billion, that's 7 gigahertz, and that which means, and you saw that each one of those tokens was coming out at a little bit less than a second per token, or it's like 2 seconds per token. And that's because I've got a 2 gigahertz processor. It's probably, if we look closely, it's probably 3 seconds. And so, because each hertz is a mathematical operation, a multiplication, and if it's got 7 billion parameters, all 7 billion of those have to be multiplied by something to get something out. It's probably got another 7 billion additions to go along with that, but whatever. If you've got time, one more question. Okay. One more, Vish. Make it simple. It's not just me who thinks they're bad at reasoning. That paper I shared with you, Google admits they're bad at reasoning. What would be good at a rule-based system? If you want to do reasoning, that's a bunch of logical expressions. It's good old-fashioned AI, GoFi. And there's a whole mass of research about how you can infer the logical patterns in the world. Like the navigation that gets you from San Diego to New York, in a split second, it can come up with that route of all those junctions. It finds that path in that maze of all the graph of connections between you and New York City from San Diego on all the different highways and how they're connected together. And that's good old-fashioned AI called A-star search. It's a particular algorithm for searching a graph. Every logical decision you ever make is a graph search. Can't explore all the possibilities. To explore a few of them that are nearby, and you just have to choose really smartly which direction you go. If you're going from San Diego to New York City, you go east and north. You do not bother with that ferry that goes out to Catalina Island. You don't even bother checking it. And so you have a lot of what are called heuristics about how you make those decisions on which road am I going to check before and see which roads are making me progress. And you have a heuristic that tells you, am I making progress toward my goal or not? Those kinds of algorithms. The book is AI: A Modern Approach by Peter Norvig and Stuart Russell, who also wrote more recently. So that book, their first edition's 20 years ago at least, and they're on their 3rd or 4th edition. It's an amazing book. Lots of fun. It'll teach you how to play chess with an algorithm, how to solve the traveling salesman problem with an algorithm approximately. Stuart Russell went on to build the algorithm that determines whether or not people are cheating on the SALT treaty. So if they hear a large explosion underground with the seismometers, is that a nuclear explosion or is that a nuclear test versus a natural phenomenon? He wrote the AI algorithm that makes that determination that's written into law in the EU. Clearly, we know how to do logical reasoning on the physical world, and we do it with good old-fashioned AI. Go find. Russell also wrote the book Human Compatible. It's about AI ethics and how you build algorithms that are humble enough to admit when they might be wrong and admit that they don't even know what you want. You need our AI overlords to constantly be asking, are you sure you want us to keep building paper clips? It looks like you have enough paper clips. And when Elon Musk says, no, I really want some more batteries for my cars, and I don't care how much the ocean you just stripped, it needs to ask all the people around him whether that's a good thing. So we need AI that's humble and not loyal. We don't want it loyal to any one person or any one government or any one entity. We want it to be humble and serve us. And that's what the book Human Compatible is all about. You're not going to get it out of ChatGPT.
All right. That wraps up the meetup. Thank you for coming. I also want to thank our speakers, both the remote speakers in Hobson, and Qualcomm for having us here. That was awesome, and JFrog for the giveaway. So thank you, and check meetup.com for the next month. I'm not quite sure where we'll be. What's that? Oh, and Tangible AI for the pizza. Thanks, Hobson. All right. Yep, that's it. You don't have to leave immediately, but eventually you have to leave. But yeah, that's it. I think I got buffering at the end because I was running out of. Okay.